All right, welcome back. We're going to be looking at similar polygons today, and we'll be using our proportional reasoning to solve problems. So in this section, I have put in some vocabulary here. Two polynomials are similar if and only if their corresponding angles are congruent and corresponding sides are proportional. So in this lesson, we're really going to be focusing in on similar, but not exactly congruent. So you can see that I highlighted the similar sides. So we can talk about corresponding sides and we can talk about corresponding angles. Okay, when we talk about shapes being similar, we use this symbol that looks kind of like a tilde if you were to take Spanish or something like that. And what we would do is we would say things like AB, that is a side that is similar to side WX, and so on. We could say that BC is similar to XY, YZ is similar to CD, and DA is similar to ZW. This is supposed to be an O. Corresponding, that's the side. Sorry, I have these switched, but the angles then would be angle A. These are actually congruent because they have to be the same exact angle. So angle A is congruent to angle W. Angle B is congruent to angle X. Angle D is congruent to angle C. Nope, that's not correct. D is congruent to Z, angle Z. And our last one is angle C is congruent to angle Y. So when you write a similarity statement, one thing to note is that the direction does matter. So notice here, if I want to talk about from A to B, that has to go in the same order. So AB is similar to RS, and BC is similar to ST, and then finally CA is similar to TR. Now we cannot change the order. For instance, for this one, CA, it cannot be RT. It's not going in the correct order. And then we could talk about the pairs of congruent angles. So angle S is congruent to angle B, angle A is congruent to angle R, angle C is congruent to angle T. Once you do that, then you can make this congruence statement about the triangle. Take a minute, see if you can answer this one, and I will go over the answer with you. Okay, I have highlighted some of the first examples. So the first one is in yellow, and that is saying that angle HGK is congruent to QPR, and that is true. Then we have this other statement, which is comparing the sides. So it's the blue side to the magenta side. That is also true. We have that these angles here are congruent. That is also true. And the last one, they're saying GHK, so that's this angle here, is congruent to QPR. So obviously you can see that even when I draw those in, the angles are not even in the same direction. So that would be the one that is false. So again, this next thing is going to be scale factor. And again, I've talked about how order matters. So in the diagram here, we're going to be talking about scale factors. And you should note that if I go from a small figure to a large figure, the ratio is written like this. If I reverse that, if I go from a large figure to a small figure, then it is written like this. So let's see if we can figure out the ratios for this one here. So let's see, I'm going to go from triangle ABC, which is the larger triangle, to triangle XYZ. So that is the smaller. So when that's the case, I'm following the first rule, which is a small side over the large side. So in this case, I only know the 3 and the 6, so I would have to take the smaller number 3 and divide it by 6, or I could reduce that to get 1/2. So when I'm going in this direction here, it's small over large. But if I go in this direction, then it is going to be large over small. So if I change that around, I'd get 6 over 3 or 2. So just remember that order will matter. So we have Tana designing a new menu for the restaurant where he works. Determine whether the size for the new menus is similar to the original. If so, write a similarity statement and write the scale factor. Explain your reasoning. So we could go through and just identify our corresponding parts. So 12 is supposed to go with 14. And we'll use 10 is supposed to go with 12, which then we want to set up a proportion, and we can just check to see if this is correct. So I'm going to go 10 over 12. Is that really equal to 12 over 14? So you're checking your cross products to see if you indeed get the same number. And on this one edge, you're going to get 144. And on this one, you're going to get only 140. So the next one will kind of set up the same way. 10 is to 8, as 12 is to 9.6. So we can go ahead and set up a nice proportion. 10 over 12, is that really equal to 8 over 9.6? You have to check your cross products there. So 12 times 8. 12 times 8 is 96, and when we do it this way we also get 96. So yes, these are indeed proportional. And so to get my scale factor, remember if we go back here, we're going from a smaller figure to a larger figure, which means we need this ratio right here, large over small. So if we look at our situation here, a large side over a small side, we should need to take 1. And so let's just take the 10 and we'll put that over 8, and we can reduce that and we can get 5/4. So the scale factor when I go in this direction is 5/4, which then means we can make a similarity statement. This is a rectangle, so I'm going to say rectangle ABCD is similar to rectangle RSTU. So this one, these answers are incorrect, so we'll just try to figure out if they're similar, and again also just decide if they have a scale factor. So if we have a small side of 6 over on that side, and we have 16 over 12, check your cross products again. 8 times 12, we had this one before, this was 96, and 16 times 6 also gives me 96. So now it's time to practice. We have to look at our shape. This side is the smaller of the two. This one is the larger of the two. So in this case, I need the ratio that is large over small. So if I take that top side, 16 over 8, I get a scale factor of 2. All right, so in this case, you will be using similar figures to find missing parts. So for instance, in the first example, kind of identify which parts are similar and then look for some unknowns. So in the first example, they're giving us here that y plus 1 is similar to 8. Now remember, we can't just say that they're equal because they're not. So you cannot say this. This is not true. But we can write a ratio. So we'll start with the blue side and the magenta side, and then we'll come up with a ratio. So I'm going to say 6 from this figure over 8 from that figure is going to be the same as 4 from this figure over y plus 1 in that other figure. This is why we practiced this last lesson. When we cross multiply here, we get 32 is equal to 6 times y plus 1. We use the distributive property. 32 is equal to 6y plus 6. We subtract 6 from both sides and we get 26 is equal to 6y. Divide both sides by 6 and we get 4 1/3 is equal to y. So that's your y one. We can also use that same strategy to figure out x. So x is here and the corresponding side to x is there. I'm still going to use these same values, 4 over 6 and that is going to be similar to put the 3 on the top and the x on the bottom. So this would be 4x equals 18, divide 18 divided by 4, and we get 4.5. So x to 4.5. Now some people will often ask, well, how do you know what goes on top or what goes on the bottom? So when you're picking the sides, okay, I'm going to call this the large shape, and I'm going to call this over here the smaller shape. And then when I look at what I'm choosing, both the 4 and the 6, they were corresponding but on opposite parts, and these were in the same figure. So you notice this 3 was in the smaller figure, which 4 was in the smaller figure, and x is in the larger figure, and 6 would be in the smaller figure. You could also just compare the parts. For instance, you could do 6 over x. Those came from the large triangle or pentagon, and then compare in the other one, it would be 4 over 3, and we end up getting the same answer. Okay, I'd like you to press pause and go try this problem on your own, and then I'll answer the question with you. Okay, so I did some color coding, trying to just see which parts were similar. For part A, you would get that 4 times 3, which is 12. That is going to equal 5 times A, which is 5A. Divide both sides by 5, and you get A is equal to 2.4. Okay, if we look at the next one, we can use 5 and 3 again, and I'm using 2 and B minus 6. So again, remember when we have the 5 and this other term over here, which has 2, you have to set it up as a distributive property problem. So you get 5b minus 30, a common mistake right there, is equal to 6. We would add 30 to both sides, and I'd get 5b is equal to 36. Divide both sides, 36 divided by 5, and we get b is equal to 7.2. All right, perimeters are similar, so we're going to take a look at this problem. Okay, so I've color coded and done some equivalent statements with the sides. The last thing would be to talk about the angles. So angle A is going to be congruent to angle J. Angle B is going to be congruent to angle K. Angle C is going to be congruent to angle L. And lastly, angle D is going to be congruent to angle M. So similarly, we can use the same fact that we have been using before to figure out similarity statements and then figure out perimeter. So let's just recall what we have some markings right here. We have that this little tick mark right here is telling us that these are the same, and it is also telling us that these are the same, and they are similar in the other shape as well. So let's see, if this side here is 7, then this is 7. If this side is congruent, then this is 4. We also know that this side has to be 10.5, and it wants us to find the perimeter. Well, we do have enough information because we can find the missing sides. So I'm going to say this missing side is x, and this missing side is y. So we'll start with what we know. I know 4 and 7 in both of them. That comes from these two numbers. So let's say we want to figure out x first. We'll put x up here. We'll put 10.5 down here. Do some cross multiplication. 10.5 times 4 is 42, is equal to 7x. Divide both sides, we get x equals 6. We can continue to use that 4 over 7. And then in the other shape, we would have 6 over y, and we don't know y yet. So we'd have 42 divided by 4, and we get y is equal to 10.5. We could have guessed that since this answer came out to be 6 as well, this side. So you could have just figured out that it would have been the same. All right, I'd like you to press pause, try this one out, and then we'll go through it. All right, in the first one, they really give us all of the parts. Now we just need to try to figure out which, what this x here and this y are. So I'm going to use these two sides, and we'll try to go figure out what y is first. I get 12 over y. Cross multiply, we get 12 times 6. And then divided by 8, we get y is equal to 9. And then our last thing would be to figure out what x is. We'll use the same ratio. Is equal to, we have 16, and we would have x on the bottom. Hopefully you can see that this one would be a nice ratio. So 16 times 6 divided by 8 gives me 12. X is equal to 12. That's the end.